Look at forces and how they affect motion. So the first thing we're going to do is put two people the same size. We'll pick one of these little blue people. We're going to put him at knot number 2. Put a red person at knot number 2 as well. We're going to run the simulation to see what happens. What do you think will happen? Record your predicted movement. Stop the video if needed at any time. Now let's run the simulation and see what happens. In this simulation, the cart does not move. These people are the same size and they are applying the same force in opposite directions, and in essence they're canceling each other out. They're both pulling with a force of 50 newtons. So we look at the sum of their forces. Because they're pulling opposite directions, we subtract their numbers because they're working against each other. The sum of the forces is 0. Because they are pulling with the same force in opposite directions, we say that these are balanced forces. We're going to return to the starting position again. This time we are going to put a red person on one side at knot number 2 and a blue person at number 4. Please make a prediction, and then let's test and see what's going to happen. Let's take a look at the sum of the values and the forces. So here we have 50 newtons to the left, 50 newtons to the right. And again, it is balanced because they are equal and in opposite directions. And the sum of the forces is 0 because we would have 50 minus 50 equaling 0. For the next one, we're going to try putting people of different sizes at the same distance. So let's change this little blue guy to a big blue guy. Put him on the third one. We're going to move this one back so they're the same distances. And as you can see from our forces up top, we have 150 newtons pulling to the left and 50 newtons pulling to the right. Please make a prediction of what you think is going to happen. Let's see what happens. Now the cart is moving in the direction of the stronger force. Now these people are pulling. Pushing would happen the same way too. The stronger force, the object would move in the direction of that stronger force. Please make sure that you are drawing the arrow and the number in there for how many newtons of force is being applied. Our forces are described by a magnitude or size, which is the number of newtons, and it is the direction that it is being applied. So this is how we describe the forces. It is a magnitude or size and a direction. All right, let's reset. This time we're going to do different sizes and different distances. If we leave the big guy at the third one and move the little guy to the fourth one, let's see if that changes anything. Please make a prediction. And let's see what happens. Again, the cart is moving to the left because that is the direction of the stronger force. Now, you've probably had experience with forces when you have played tug of war. The side that pulls with a stronger force is the one that will win that game. For the next one, we are going to put one large person and one small person on the same side. We want to see what happens when the forces are going in the same direction, what we do with those numbers. We saw when they're going opposite directions, we subtract the numbers to find the sum of the forces. What do you think we're going to do with numbers if they're both going in the same direction? Please make a prediction for the movement, and let's see what happens. So it is moving in the direction of the force, and let's see what happens with the sum. So in this case, the forces are going to be added. The little person will apply a force of about 50 newtons. The big person is a force of about 150. So we are adding the 150 for the big blue person and the 50 for the little blue person, and that gives us the 200 in the left direction. I'm going to go ahead and restart. This time we want to take a look and see what happens when the cart is already moving. Okay, we've looked at objects at rest, but every time we've run this simulation, the cart has been at rest. Let's see what happens when we apply forces when the cart is already in motion. We've seen that if it's balanced, the cart doesn't move. When it's unbalanced and one force is stronger than the one going in the other direction, then the cart moves. Let's see what happens when the cart is already in motion and we play around with these forces. So we're going to put a big person on the side that's red, and we're going to get it going here. Now we're going to add a person to the opposite side, and it's going to be the same size person at the same distance. Please make a prediction of how you think the cart will move. So let's see what's going to happen. Currently, the cart is moving towards the right, towards the person that is pulling. Again, we're going to put the same force at that same location, and look, the cart is still moving. That cart still moves. Let's run that one more time to make sure that we understand this. We've got the person there, they get it going. We're going to put the other person here and watch what happens. Because that cart is already in motion, when we apply a balanced force, that cart does not have any resulting force being added to it. So it is going to continue moving in the same direction and at the same speed that it was already going. Even though we have that person now pulling on the other side, we have balanced forces acting on the cart, and the motion of the cart does not change. The motion of the cart does not change. So they will continue to move that cart because it was already in motion. All right, this time we're going to start it with the big person, and we will get that cart going. And we're going to add a big person, and we're going to add a little person. Let's see what happens. Hopefully you made your prediction. The cart was still moving in the direction of that stronger pull that started it, and then we balanced it with the big person. But because we've added the little person now in there, the forces are stronger going in the left direction, so they're able to pull that cart back. It doesn't happen as soon as that other person gets added. They have to overcome that force going to the right with those forces pulling to the left. And again, if they're going the same direction, we add them. So it was 150 plus the 50. And then because this one's pulling in the opposite direction, we subtract that force and we wind up with 50 newtons to the left, and the blue team winds up winning. Hopefully this was a quick visual representation of how forces work. If they are balanced forces, the object keeps doing what it was already doing. If it's at rest, it stays at rest. If it is already moving, it will continue moving if the forces acting on it are balanced. Unbalanced forces are needed to make an object change its motion.